This clip covers torque and drag calculations in and over engineering. So what I've done is I've started with the BHA example that we created in the Creating a BHA video. If you haven't watched that yet, go and watch that first, because that will get you to this stage. Once you've got a BHA in place, then what we need to do is fill out the rest of the information required for the torque and drag calculation. So in this case, we've got our drill string and component details input using the BHA example. Next, we have to fill in the weld geometry. So the weld geometry depicts the inner diameter of the weld bore. So if you've got, say, 3 casing strings, one at the surface, then one run inside that, the only one we care about is the one that is physically now the ID of the weld bore. So in this case, we're going to have a 9 5/8 casing string run to 5,000 feet. And then we're going to have open hole down to 15,000 feet. And we don't have a TVD yet because we haven't input the survey data, but we'll go ahead and do that in a moment. Next, we'll go ahead and input the fluid properties. So we've already input a mud weight, but we'll need a PVYP as well. So calling it ore-based mud, I'll put in something along the lines of 22 PV, 25, 12 PVG oil base. We'll save that. Next thing I'm going to do is move on to the Surveys tab. So here you can select whether you're inputting actual surveys or well plan data. In this case, I'm going to input well plan data. So start off at surface, then it's going to be vertical till 5,100. Then we're going to kick off. Hold that 15,000 feet. Okay, so we've input a well plan there. This is also copy and paste friendly, so we can just copy from a well planning software and pull it straight in, or any reports. Once we've got that in, hit save, go back to my weld geometry, just reselect that, and the TVD updates. Okay, so now we've got our surveys. Next is to go to engineering parameters. So this hydraulics section we don't need to worry about for now. The torque and drag section is what we need to concentrate on. So our calculation depth is going to be the TD of the section. It doesn't have to be the TD of the section. You can look at any part of the section that you're going to be running, but to get the full picture, in this case, put in 15,000 feet. RPM is going to be 120 RPM. Pipe speed 30 feet per minute. Weight on bit 30k. No overpull. Block weight 35k. ROP 110 feet an hour. And then we come to the friction factor section. So in this case, I would normally, for an ore-based mud, run it somewhere in the region of 0.5, 0.5, and leave it so that it puts in a automatic increment. So you run it on 5 different friction factors. If you select manual friction factor increment, it only puts the ones that you've written. I'll uncheck that, and we've got a range now. Save that data. So we filled in the torque and drag section. We also need to select the correct survey selection. So if you remember, we input data into the well plan section. So we need to select well plan. Another thing to select as well is a flow rate. So in this case, the flow rate is important because that affects the differential pressure. And the differential pressure affects the weight of the string and the buckling. So in this case, I'm going to input 450 GPM. And again, that does a manual increment, or you can run it at 1 increment. If you have it as 1 increment, the flow rate at the top of the list will be the flow rate used in the torque and drag analysis. And if you're using the automatic increments, it will be the flow rate in the middle of the list. that is used in the torque and drag analysis. Okay, so we've input our drill string, weld geometry, fluids, our surveys, and our engineering parameters for the torque and drag calculation. The only other thing we need to check is in our options for torque and drag model. So there's various different options that you can use for running the calculation. In this case, because we're running a motor, I would select the buckling lines to sliding, and buckling model to standard for US welds. And that is all I would generally change at this stage. But again, you can change these options depending on the circumstances. Once you're ready, hit calculate, torque and drag. And the torque and drag calculation is complete. You'll now see that the very quick look hook load and torque data has been filled in. That's evidence that the calculation is completed. So where you actually view your results is TAD results, torque and drag results, and results are depicted in the forms of charts, so drilling charts and snapshot charts, as well as the data that those charts are created from themselves in tabulated data, and a torque and drag summary report. So quick and easy one to look at is this torque and drag summary. It gives us the input parameters that were used for the analysis, and then it gives us a very quick breakdown of the results of that analysis. This can then be saved to anywhere within your computer. Again, looking at the charts, we have hook load chart. Again, editable functionality. And the actual data the charts are made from. Again, this can all be exported. That completes brief introduction to torque and drag analysis within Weld Pro.